Hey guys, I got this question last night through text, which makes me very happy because it means you're watching your homework help videos. And maybe I wasn't quite clear on doing U substitution, which was a technique you would have learned right at the end of Cal 1. So I want to simplify that or kind of help you understand that a little bit. So in the base, this was like number 5 on homework 6-1. You in the question, you get down to this point where you have to integrate the integral from 0 to 11 of e to the -2/11 x dx. And if you look on your integral sheet, your derivative and integral sheet that I handed out, this is number 5 on that sheet. You'll see it's that integral of e to the u du is exactly just e to the u plus c. So what's so exciting here is that the antiderivative of e to the x is just e to the x. The derivative of e to the x, e to the x. The only function that is its own derivative. So it's pretty cool little thing about e to the x. But we're not dealing with e to the x. We're dealing with e to the -2/11 x. So how do we handle that? We handle that through this method of substitution. We say, okay, instead of e to the x, I'm going to say I'm going to have e to the u. And what is my u going to be? Well, I'm going to decide that my u is this part right here, this -2/11 x. So u equals -2/11 x. Now I want to make this integral look like this one. So instead of dx, I need a du. So I'm going to go ahead and take the derivative of this substitution. What is the derivative? If u equals -2/11 x, what is the derivative of that? Well, du, and you could actually sort of say du dx if you want, is equal to -2/11 because the derivative of a linear function is just the constant in front. You know, derivative of 5x is just 5. Derivative of -2/11 x is just -2/11. Now, when we're doing this U substitution method, we kind of multiply through by this dx. This could actually, if anybody's really watching, there's a lot of math going on underneath there, but we can really want to think of this. We'd really rather think of that du as -2/11 dx, which is completely legal. Okay, so now we say to ourselves, wait a minute. I still have this dx here, and I ended up with -2/11 dx. I really just want dx. So what I'm going to do is in this equation that I found, du equals -2/11 dx, I'm going to go ahead and solve, just regular algebra, solve for dx. So dx is being multiplied by -2/11. So the way that you would solve for it is divide by -2/11 or on both sides, or multiply by -11 halves. Either way you want to think about it to kind of isolate that dx. So you're going to have -11 halves du is equal to dx. Okay, so now you're going to be able to pop in -11 halves du. You're going to pop that right in for your dx. Now, what about your limits? What about these guys? What about the 0 and the 11? There's kind of 2 ways to do this. I personally like to go ahead and change these right away. I'm going to convert the entire integrand in terms of u. So remember, currently, these limits are x limits. I need to make them u limits. So I'm going to say to myself, all right, well, when x equals, when x equals 0, because that's that bottom limit there, when x equals 0, well, u will equal -2/11 times 0, which is just 0. And when x equals 11, u will equal -2/11 times 11, which is just -2. Okay, so now I'm completely ready to change this integral into its into being in terms of u. So the integral from 0 to 11 of e to the -2/11 x dx is going to become the integral from now the u, when x was 0, u was also 0. So from 0 to when x was 11, u was -2. And then it was e to the u. Instead of dx, I'm going to write -11 halves du. Now, typically, you'll see me put that constant out in front. I wouldn't put it there, but I'm just kind of letting you see that I made that direct replacement right in there. So now I'm going to take that negative 11 halves out in front because it's a constant, so it just tags along. Integral from 0 to negative 2, and then it's e to the u du. Now, my formula from my integral sheet tells me that the antiderivative of e to the u du is just e to the u plus c. In this case, we have a definite integral, so we don't have the plus c. So this is just going to be the negative 11 halves tags along, negative 11 halves, and then it's going to be e to the u evaluated from 0 to negative 2. And then again, the negative 11 halves tagging along, applying the fundamental theorem, just plugging those numbers in, you'll have e to the negative 2 minus e to the 0. And e to the 0, of course, is just 1. So this is negative 11 halves, e to the negative 2 minus 1. Okay, so I hope that kind of clarified some of that substitution stuff for you.